All right, let's get started with the introduction to Maxeon solar panels. This is one of our green tech renewables suppliers and presented by Green Tech Renewables. So Maxeon solar panels. We'll do a quick introduction to Green Tech, and then we'll introduce the Maxeon team, and they will present on the product, and we'll have time for questions and answers throughout and definitely afterwards. So let's jump ahead to the getting started slide. Data sheets and additional resources are available in the sidebar in the control panel under handouts. We'll do the Q&A session at the end, but please submit questions anytime in the chat box, and we'll organize the questions and start working on the answers during the presentation, and we'll start the Q&A right afterwards. And then of course we'll do a recording of the event, and that will be emailed to all the registrants following the webinar if you want to follow up on the presentation. Thanks. Let's go to the next slide. Presenting representing here is Green Tech Renewables Engineering. I'm Stuart Fox. We are an engineering team that works inside of the Green Tech network. Any Green Tech account can have 24/7 access to the entire design team for pretty much any kind of project and anywhere in the United States. Carports, batteries, HOAs, military projects, on-grid, off-grid. We do almost any kind of project, and you access the design team for permitting and technical sales through your CED sales rep, which gets us to the next slide. Green Tech Renewables, we're committed to providing customers with exceptional service, of course, and top-tier products from prominent renewable energy manufacturers. We're the leading solar distributor in the country, a local network with over 90 locations all over the US in all the major solar markets. If there's a solar program in the US, then there's probably a Green Tech nearby. Our warehouses have always been purpose-built for will call construction, extensive on-site inventory and logistics support, and everything from start to finish for any project. Of course, our core values are service, integrity, and reliability. So that gets us to next slide, please. Again, I'm Stuart Fox from Green Tech Renewables, head of engineering, and now I'll turn it over to Maxeon team to introduce themselves and get the ball rolling.
Thanks, Stuart. Darren, you want to just go ahead? We'll go in order here.
Hey everyone, my name's Darren Hoffman. I'm actually based out of Australia, but I'm one of the sales and technical trainers for Maxeon here, and I'm very, very happy to be here, and look forward to taking you through some interesting content in a little bit.
It's early in the morning, so we're very grateful that Darren has made time for us. I'm Spencer Collette, Maxeon Director of Sales for North America, Residential and Commercial. I don't have the attendee list, although I'll get it for the webinar, but I'm guessing I am a familiar face to some, new face to others. So quick background, I spent about 6 years at SunPower back in, that stint ended in 2016, as an RSM, then as an area sales manager. Since then, I took on, love the product, and very, very pleased to be representing it again. Between then and now, took on a couple of solar roofing projects. Most recently ran the channel team for Tesla for the solar roof product, and have been back here with Maxeon for the past 5 to 6 months, working on hiring up the team and standing up this business.
Yeah, and
over to you, Zach.
Yeah, thanks, Spencer. So I'm Jack Campo. I'm actually based out of Europe. I started at SunPower about 2010, and R&D, and have kind of worked with SunPower Maxeon throughout the years, and currently, obviously work with Maxeon side since the transition. Background in engineering and business, and again, just based over here in Europe, but basically have kind of support the whole world, including Spencer. So pretty excited to see our North America business starting and being able to present to you guys today.
Thanks, Zach. Okay. Well, welcome. We very much appreciate your attendance today. I'm excited to take you through sort of the beginnings here of what we think will be a long and fruitful relationship with many of you in the North American market. Quick agenda. We're going to talk about some launch basics, talk to you a little bit about the company, try to clear up any confusion between, what is Maxeon, what is SunPower. We'll talk to you about the product that we're launching with and the program that we are launching here in short order. Then we'll spend the majority of the presentation on a technical deep dive. So just talking about the differentiation of the product, what that means in terms of features and benefits to your customer. And then we'll round the presentation out with a quick kitchen table snapshot. So this is sort of an illustrative look at 3 different systems and or proposals that an average homeowner might see and how they stack up. Okay. Quick basics on the company. So we're a very old company, right? This is a company that's been leading innovation in the space for 37 years. We were founded in Silicon Valley in 1985. We hold over 500 patents. We have over 48 million modules in operations right now, and we have just over $1 billion market cap and are publicly traded on the NASDAQ. We were also just named one of the 100 most sustainable companies in the world. You can see the chart over here on the graphic here on the left, showing some of our competitors and the lengths of time that they've been in the business. We clearly eclipse virtually all, and you can see that we've been there from the start, and we are still 100% committed to PV. Many of the other companies there, have other businesses and were in PV long ago, but have exited. And then many others that we compete with today started long after us. So very committed to the industry and here for the long haul. You see SunPower and Maxeon on the graphic there, so I did want to talk about that briefly. Maxeon operates the SunPower brand in every market outside of the United States. So SunPower, as you know it, SunPower North America is the downstream entity in the US, also a publicly traded company. We manufacture modules for SunPower. And then lastly, quickly on Maxeon again, we're a global company, as mentioned, SunPower based here just in the US. We've got over 1,700 sales and installation partners internationally and over 5,000 employees internationally. And you can see the list of customers there. We provide cells to SpaceX and Blue Origin. We've done a number of projects for Prologis. We're doing a Google campus right now. We're on the Apple campus as well. So, for those who are most concerned with quality, longevity, and sustainability, we are the clear choice. Okay, quick launch basics. So the product is available now exclusively through GreenTech. I believe we've shipped to 6 locations so far. We will ship to 19 GreenTech locations so far this quarter. There is some additional product available for Q1, so I want to be really clear about the fact that there is product available, and there is additional product available for your GreenTech PC should they not have placed a stocking order for Q1. So if you have questions about availability for your local market, talk to your GreenTech PC, but product is available. We're currently staffing a sales team to support you guys with training and just ongoing support. This is a differentiated product. It requires a bit of a differentiated skill set to sell effectively. And so we know that we need to staff a direct team to work directly with you. We have 3 sales reps signed now coming on, one in the Northeast, one in California, and one in Texas that will all be onboarded within the next 2 to 3 weeks. So I'll introduce them to their GreenTech counterparts first, and GreenTech will help us introduce them to you. By the end of the year, we should be closer to 7 or 8 RSMs, and we'll continue to grow the team from there. We're also launching a partner program sometime in February, ideally at the beginning of February. So this is a channel program, much like you've seen from other panel manufacturers. We will have a couple of tiers. We want to have close relationships with our installer partners, and so we want to do that through this channel program. And we want to use things like co-marketing dollars, potential access to differentiated finance offerings as a way to maintain a really sticky relationship with you guys. So look for more details on that to come. And then quick info on the product. So the product that we're launching with is called the Max 3 112 cell AC ready module. Everything for the first couple of quarters is going to be black on black, and the majority of the volume this year will be all black. Right now we're shipping a 410 and a 415 with a max efficiency of 22.2%, and every one of those panels comes with a 40-year warranty. Okay. And I'm going to turn it over to Darren to talk about the Maxeon Advantage and our unique advantages in efficiency, reliability, and then our warranty.
Thanks, Spencer. Yeah, so I'm going to take you through how we differentiate on a technology level. Any of the information that we present here is also based on third-party validation, so it's not exclusively claims that are being made by us. It can actually be substantiated by others as well. So to do that, to manufacture a better product, and we feel we've got the best product on the market, you first need to understand how they fail. So there's been numerous studies done into the causes of how and why panels fail in the field away from standard test conditions. So this particular study, it was done by DuPont Global on PV reliability, and it was very extensive and conducted across 3 gigawatts worth of installations. The study identified that hotspots and internal circuitry issues, along with cracked cells, they account for over 60% of failures. And surprisingly, up to 30% of those issues occur within 10 years of installation. So that's well within the warranty period. And they certainly continue to increase in frequency over time. Interruption to the energy flow is what causes hotspots. And that is usually in the form of a shaded or cracked cell, which causes the affected cells to operate at higher temperatures. Now, this can degrade the surrounding panel materials, including the glass and the encapsulant, as you can see in this graph. Thanks, Spencer. So if we know that hotspots and circuitry issues are the reasons for panel failure, how does that relate and happen out in the field? So in the form of shade, it can be a fallen leaf, as it is in this example, but it could be the buildup of some soiling or a shadow from a chimney throughout the day that can interrupt the energy flow. And then as far as cell cracking, there's a phenomenon called thermal cycling, and that puts stress on the cells at the connection point between the cell and the contact ribbons, which is how a conventional panel is engineered. Using those front contact ribbons, which are made of different materials than the silicon, as the temperature changes throughout the day, the cell and the metal contacts want to expand at different rates. And this puts stress on the panel components at the cell to ribbon connection point. And these can fatigue over time and will eventually break. Now, if the temperature in the affected cell heats up enough, the bypass diodes will activate to protect that portion of the panel. Now that's a good thing, but unfortunately, with persistent activations, the diodes can fail over time as well. A recent field study in Japan found that 47% of panels had defective bypass diodes after 10 years with daily partial shading. Next one, and the follow-on effect is that once the diodes, that's okay. The follow-on effect is that once the diodes fail, it leaves the panel unprotected. So shaded and cracked cells and the temperatures continue to increase, and they can get high enough to cause breakage to the glass and damage the backsheet. So what differentiates Maxeon IBC technology is that it's designed to engineer out how conventional panels fail. It's built on a solid copper foundation. Maxeon has all the circuitry and electrical connections on the back of the cell, and that eliminates the need for the front contacts and bus bars. And built on that solid foundation, it's highly flexible, so it protects against cell cracking. We've got patented electrical tabs at the connection point made from the same tin-plated copper that run the length of the cell to provide a solid electrical connection. And there are also gaps engineered into those tabs that allow the cell to expand and contract freely without placing any strain on the connections or the cells themselves. And that eliminates the effects of thermal cycling. Now, having a copper-based cell doesn't stop the panel being exposed to shade or soiling, but it does allow the panel to manage the problem more effectively. And if we look at this table, it highlights the Maxeon IBC panel compared to other conventional panels in a shaded scenario. Now, a solar cell that is shaded or severely cracked doesn't produce the same electrical current as the other cells in the panel. And electrically, the affected cell is still driven to match the current of its neighbours, and it begins to operate in reverse. And it converts that power from the neighbouring cells into heat. Now, in standard cells, this heating tends to occur in a concentrated area of the cell, and that causes the hotspot. Now, these hotspots can feature temperatures high enough to degrade panel materials. And as I said, to mitigate the hotspot development, bypass diodes in the junction box are employed to avoid the sections of the panel that's got the affected cells in it. But it's got a limited effect. The Maxeon cell, however, running in reverse demonstrates a lower heat generation, and it's spread across the entire surface area of that cell. As a result, the diodes in a Maxeon panel activate less frequently, so it increases both the production and the useful life of the panel. And the Maxeon cell operating in reverse run at a much safer temperature as well, so it does greatly extend the life of those panel materials. So when a Maxeon IBC cell is configured into a panel, they're effectively hotspot protected as a direct result of better engineering. The solid metal foundation on the Maxeon cell is highly flexible and, as I said, crack resistant, so cell breakage are much less of an issue, and will still maintain an electrical connection and produce current even if there is a crack. Shading is also less of an issue, and coupled with our painted tabs at the cell interconnection points, they provide a secure pathway for energy to exit the panel freely. Also, I want to briefly discuss efficiency. A nameplate rating on panels at standard test conditions is not necessarily a reflection or a true comparison of performance at those non-optimal times. So when we're having a discussion about how Maxeon panels will generate more energy per rated watt, it's key that the end customer understands that the Maxeon panel is engineered different and will outperform competitor panels over the life of the product. In this comparison, both panels produce 400 watts at standard test conditions, which is about as good as conditions can get. The three comparisons that you see here are the reduction in energy you could expect from a Maxeon IBC panel and a conventional panel. So when subjected to the same amount of shade as in a PV-SYS simulation like this one, the Maxeon cell is still producing an additional 76 watts compared to the conventional panel. And in the middle comparison, the output is based on published degradation rates, with the Maxeon warranting an additional 7% output in year 25. And then the third difference is a yield-based comparison on data sheet temperature coefficients. So you can see that there's still more energy production based on better efficiency. And I guess what I wanted to highlight from this slide is that when you're comparing efficiency, particularly at standard test conditions, that not all watts are created equally. Still talking about efficiency, I think it's interesting to highlight the evolution of PV cells over the last years. Starting back with polycrystalline cells that were into the emergence of cells that were being produced from a single piece of silicon into the monos, and now into the newer technologies that are emerging with HJT coming onto the market. Now, all of those have had advances in performance and efficiency, but fundamentally, they're still produced in the same way with those printed metal bus bars and thin interconnectors between the cells. Maxeon's had the ethos from its inception to manufacture a product that has engineered out those common failure modes, and we're in our 38th year of doing so. And we've had that Maxeon cell since way back before I started in 2008. So it's been there as the benchmark for a very, very long time. So this is a summary of what the difference is effectively between the technologies. And the HJT it can claim to harvest more energy with the way that it's produced. As I highlighted before, though, the standout point is that it's still got the same architecture it has before. And we're also seeing that some of the degradation rates that are in those panels are higher than what we're seeing warranted on a warranty document, for example. So it's a new technology. It has got some really good, excuse me, high-level benefits from an efficiency point of view, but you still need to be aware that over time that it may not be as necessarily reliable as what warranties are claiming.
Yeah, and I think we wanted to highlight HJT simply because, you know, no secret, that's really the most competitive technology with IBC in this market, right? It's TOPCon in Europe, it's HJT here in the United States. And they have done a lot, you know, this technology has done a lot to catch up to us in terms of efficiency and nameplate, but it's important to understand that it, you know, HJT cells and modules still don't have a structural backplate, and they still have, you know, printed bus bars on tops of the cells, and they still have thin connections between the cells instead of a solid connection with a built-in strain relief. And all that leads to performance that does not equal an IBC's performance in the real world.
Cool. Excuse me. And then just to summarize the technology advantages, here's exactly what you get from Maxeon. Back to my initial slide, Maxeon can engineer out 93% of the ways that panels commonly fail. It provides unmatched shade and hotspot performance, and we can demonstrate this across all climates. We've got installations on every continent, and we've even got installations in the Arctic regions. I'm not aware of any other manufacturer publishing their rate of returns, which is a really good measure of reliability. Maxeon's held a return rate of 0.005%, and it's engineered to a 50+ year design life, so it's exceptionally reliable and durable. We launched the 40-year warranty on the IBC product in 2022. And we warrant that the panel will still be performing at 88% of its nameplate rating at year 40, which is similar to what most of the others are doing at year 25. The 40-year warranty is all inclusive. It'll cover shipping and the associated installation costs if there's an issue.
Yeah, and I just want to touch on the return rate as well, because I think this is interesting. We wouldn't print those, but I can certainly say it. That return rate of 0.005% since 2012 is actually a bit of a hedge. So that's 50 parts per million. The real number is 38 parts per million.
And then also want to talk a little bit about sustainability. So apart from engineering a great solar product, it's critical that we produce it in the most sustainable way possible. And there's little point in producing that product to save energy and fossil fuels if it's not produced in a sustainable way with the least possible impact on the environment and its people. At Maxeon, we've got numerous certifications, including one from Corporate Knights, most recently nominating Maxeon as a top 100 sustainable companies globally. But I'd also like to highlight these three. So Maxeon's the first and only solar company to adopt the International Living Future Institute's Declare label, where we openly disclose all of the panel materials used in the production of our product. Our Mexicali plant, our Mexicali panel manufacturing plant, they achieved the solar industry's first and only zero waste to landfill certification, and it's held that since 2015. The certification published by NSF requires no greater than 1% of material from that facility sent to landfill, and no more than 10% of the material is sent to a waste to energy facility. Maxeon solar panels are also the first to be cradle to cradle certified, and they've held this certification since 2014. Cradle to cradle certified products is a globally recognized standard, and it's a measure of product sustainability assessed across 5 different categories of material health, material reutilization, renewable energy, water stewardship, and social fairness. And overall, the Maxeon IBC panels were awarded a bronze certification under the cradle to cradle criteria. Please know that sustainability and ESG is incorporated into everything that we do, and that's from the sourcing the raw materials, production of our panels, and the facilities that they come from, giving our customers the highest quality, most reliable products produced in a socially and ethically responsible way. There's a whole wealth of information on how we address sustainability and ESG, including a comprehensive sustainability report and modern slavery report that's available on our website. So for a bit of extra reading material, I would really encourage you to take a look at those.
Yeah, just given all the issues with module availability in 22, and I think these things will probably continue in one shape or form or another. I think it's important to highlight that we were never subject to the WRO in 2022 or the trade case that held so many containers up in port. All of the modules that are being produced for the U.S. market are produced in Mexico and are imported under the NAFTA governance. So a very clean product produced in a very clean way. That's always been at the core of sort of the ethos of the company, and I think it's showing real world impactful results to installer businesses today. Okay, go ahead, Darren.
Okay, so as warranty, as I said, we launched the 40-year warranty last year, and it's been a great testament to how the product performs over time. And I think when a lot of people look at payback terms, they look at it as a metric to measure how they should purchase, and it's not necessarily the best way for a customer to have a look at it, because it can hide some real value. And this slide here tries to demonstrate that solar is definitely a long-term asset. In accountancy terms, you could look at NPV or levelized cost of energy. They're probably more meaningful criteria, but for mums and dads, it's a matter of how much am I going to get back from the panel or the system over time. And if we look here, we highlight what the initial cost is and what the delta is, or what's left over in payback after that cost is paid, after that initial purchase cost is paid. So here we can see that during the life of the system, they deliver more value as they produce more energy for longer. And there's less ongoing costs or potential risks from a Maxeon system. The payback is a little bit, on the initial purchase, is that little bit longer, but it's greatly extended, particularly when you add the 40-year warranty to it. This is also a more sustainable option. So the US National Renewable Energy Labs, or NREL, also produced a report late last year saying that model lifetime extension should be prioritized over closed loop recycling to reduce the demand on raw materials. And that's what the 40-year warranty does. So it's a really good measure of that. So I guess it can be a question as to whether the customer is interested in the initial cost, the cost recovery in the initial years, or the investment and the real value that's created over time.
Yeah, and I think warranty term becomes or has become even more important over the past, let's call it 3 or 4 months, as solar has gotten more expensive, right? Labor got more expensive in 2022, equipment got more expensive. Now money is getting a lot more expensive. And so there's sort of a natural inclination, especially in the lower cost of power markets, to try to drive cost out of an installer's price to the customer in order to keep costs low, especially in markets where the economics are super thin. I would argue that in those markets, because the investment is a longer term investment, the equipment, the company behind it, and the warranty behind both are even more important. Okay, some particulars about our 40-year warranty. So year 1, 98% output, an annual degradation of 0.25%, which gives us an output warranty of 92% at year 25 and 88.3% at year 40, which is kind of remarkable, frankly. I don't know of any other product that is supposed to perform at nearly 90% of its day 1 output at year 40. The warranty also covers removal of any faulty panel, shipping of that panel, shipping of the new panel, and installation of the new panel. So you can see that we have an extremely high confidence around this product and have put a warranty around it to show that. Okay, so the product is the best product on the market. I wouldn't even say we believe it is. It is. I think it's fairly widely known in the industry that IBC is the superior cell technology compared to anything else. That's why you see it being shipped to and sold to SpaceX and Blue Origin and NASA, right? If you really, really need it to work and you need to know that it's always going to work, you buy IBC. The question is, does value exceed price? Because another thing that most folks on this call probably know is that IBC has always been more expensive than everything else on the market. It is a true 40-year product. It is the highest efficiency product on the market. So it is a top of market product. So let's take a quick look at three proposals that, or numbers from proposals that the average homeowner might see in an average market for both production or yield rather, and power pricing. Now I want to say something really quick, a quick disclaimer here before we look at the numbers. I am going to show pricing, not panel pricing, but system pricing. And I want to be super clear that this pricing is indicative. It is meant to illustrate a concept only. So don't get super hung up on, oh, this isn't what pricing looks like in my market, or the cost of power is super low compared to my market, cost of power is super high compared to mine. The same concept will work in any market across the United States. It gets better, obviously, just like everything else does, customer economics wise in this business, as power gets more expensive, and it still holds as power gets even cheaper. So again, pricing is indicative. For pricing on our product, contact your GreenTech PC. Okay, so three module types that the average homeowner in the US might have a look at when they're considering going solar. So Maxeon, the only IBC product on the market, HJT, and Mono PERC. I've used our highest output currently module, the 415, the highest output HJT module that I'm aware of, 410, and a 390 Mono PERC. And I'm giving illustrative pricing for the modules here. So we're using a baseline cost of $2.75 a watt. And what that includes is everything except for the module. So inverter, racking, BOS, administrative costs, and contractor margin, everything but the module. So that gives you a cash price of $390 a watt for the Maxeon system, $370 a watt for the HJT, and $350 a watt for the Mono PERC. Now, we're going to bake this into a loan that's a 25-year term, so 300 payments, with a dealer fee of 34%. Oh, and an APR of 399. I'm sorry, I didn't show that. Yeah, APR is 399 and dealer fee of 34%. So that gives you a finance price of $523 a watt, $496 a watt for the HJT, and $469 a watt for the Mono PERC. Okay. So 22 modules each for Maxeon and HJT. I gave Mono PERC a 23rd just to be exceedingly fair for our target system size of 9 kW. So that gives us a 9.1 kW system, the HJT option, a 9 kW system, and the Mono PERC option just under 9 kW. So here are the loan amounts less the ITC, and those result in a monthly payment of $176, $165, and $155. So an $11 premium per month over heterojunction for Maxeon, and just under a $21 premium per month for the Mono PERC. Okay, so let's see what this looks like when we look at yield and savings. So these numbers come from PV simulations that were done in Fort Myers, Florida. Conditions are relatively ideal, so virtually no shading, close to south facing. So in year one, we'll produce 14,955 kilowatt hours. The HJT system will produce 14,621, so about 1% less kilowatt hours per kilowatt power rated. And the Mono PERC system, 13,877, so about 5% less kilowatt hours per rated watt versus the Maxeon system. We're valuing power at 15 cents a kilowatt hour, and I just netted this out to make it super simple. So the value of that production in year one is as follows. Now we've modeled degradation for each system based on real world results, essentially. So ours at 0.2, HJT at 0.67, and Mono PERC at 0.94. And these correlate to the graph that we showed earlier on the heterojunction slide. So that gives you the following 25-year yields, and you can see that we have, as you would expect, a substantial advantage there. So the value below, based on a 2.5% escalator per year on power, is 74,000, just under 75 for the Maxeon system, 68 for the HJT, and 62 for the Mono PERC, which gives us a $6,000 advantage, 25-year savings versus HJT, and just under a $12,000 advantage versus the Mono PERC system. So of course, as mentioned, our price is higher, right? There is a payment premium up front. Now, we don't expect most of these customers that are taking out 25-year loans for solar to actually pay them to term. But if you did, if you look at a $10 and $20 premium per month, us versus HJT and us versus Mono PERC, and you assume that the customer is going to pay the entire thing all the way to term, so 300 payments, that would equal a $3,300 premium, all told, Maxeon versus HJT, and a $6,200 premium, Maxeon versus Mono PERC. However, if you look at the savings, which we do better in, 6,000 better versus HJT, almost 12,000 versus Mono PERC, and you net those two things out, you'll see that the Maxeon system is actually cheaper or saves you more money over time. So our 25-year net savings advantage is $2,700 over HJT and $5,500 over the Mono PERC option. So this is really what this product offers. It offers you a differentiator at the kitchen table, and it offers you a true top of market product. If your sales team or you can sell the homeowner $10 to $20 a month in premium, the value that you can give them is as follows. You get a true, and they get a true 40-year product from a 37-year-old company. They get 10 to 20% more production and savings over the first 25 years. They get the industry's most durable and reliable module, so peace of mind. They get the industry's most sustainably sourced and built module. They get the industry's best on-roof aesthetics, no lines on the front of the cells, all black. They get the highest efficiency module on the market and an unmatched 40-year warranty for total peace of mind on a long-term investment. Okay, and that's what we have prepared for you guys. So I think with that, I'll leave this up for just a second so you can scan the QR code if you'd like, but in just a minute, I'll stop sharing and we can go to questions. Okay. Okay, Christy, did you want to start sharing questions?
Sure. Hey guys, let's take a look at the questions. Feel free to type them in, and I will try and get to most of them if I can. So I'm gonna go down the list here. Is the 40-year warranty valid in the Cayman Islands? I'm gonna start with that one.
That's a good question. I will find out. Let me take that note.
We're gonna find out for you. Let's see.
If it's not, it should be. So we'll make sure that it is.
So there's a question here about SunPower, the relationship with SunPower, any sort of competing interests, how we're managing that. Is that an issue that we're concerned about?
Yeah, I can't see that one, so I can't see the full question, but I'll try to speak to it. No, it's not a concern. What we're really trying to do is capture a different part of the U.S. customer base. So, as you well know, SunPower is not just a panel, right? They provide an IBC panel that Maxeon supplies them, but it's an AC module. They wrap that in, a full system warranty. They provide the racking as well. They provide leads to their installers. So it's more of a, I call it like the big hug, right? They provide financing as well. Maxeon is looking to access the part of the market, installers that really are looking for a little bit more independence, I think. Who want more independence in terms of what MLPE they pair with the panel, what storage they pair with the panel, what financing they use to sell the panel. So the relationship for now is strong, right? We just signed a supply agreement with them that runs through 2025, and we very much would like to sign another supply agreement with them that extends that after that. We're simply launching as Maxeon in this market to access a different portion of it.
Which PCs are going to have product availability?
Oh gosh, good question. Let's see. Off the top of my head, most of the PCs in California, Seattle, Denver, most of the PCs in the Northeast, and any other PC that you bug to order product from us.
Another question around SunPower. Looks like the frame profile hasn't changed. Does that mean that Maxeon will sell the same SunPower racking system?
We will not. But you're right, the frame has not changed.
Does this qualify for Buy American?
No, it does not. Correct, Zach?
Yeah, the panels for the U.S. market are made in Sonata with cells from the Philippines. So there's, we managed to definitely steer very clear of the poly situation out of Asia, but the Modco is not in the U.S. So it doesn't strictly actually the cell and the Modco are not in the U.S. So it doesn't strictly qualify for Buy America.
Question about, is this an AC or a DC module?
Yes.
This is a DC module, only for now.
I wrote an answer in the chat, but to answer Trevor's question about this, the reason we say AC ready is that IBC cells, and as well as our design of IBC cells, tends to have high voltage relative to other cells. So when you put 112 of them in series, you tend to get pretty high voltage to the point that you could be at 70 or 80 volts, which doesn't play nice with a lot of MLPE or module level power electronics like microinverters, inverters, rapid shutdown. So because MLPE is huge in the US market because of the rapid shutdown requirement, we basically did what we call parallel busing in the panel. So you can effectively double the current and half the voltage. And you get something that's quite compatible with AC, and hopefully you guys can see that answer. But it's super compatible with basically any MLPs that out there on the market, and we designed it just to play very nice with what's in the US.
Yeah, and actually GreenTech has our full MLPE compatibility guide. I don't see it as available in the handouts, but my view as a presenter is a little bit funky. So we could include that in whatever gets sent out to attendees after the webinar.
Yeah, the module data sheet is in there. I see it, Spencer. So if somebody needs a very fast answer, they could grab the specs off of that.
Well, and the module is also in the In-Phase design tool and the SolarEdge design tool. What else?
Question around what does IBC stand for? I don't know if we covered the actual acronym.
It stands for interdigitated back contact. Zach, you want to say anything about that? Feel free. But that's essentially the underpinning of the technology.
Thanks, Spencer. Not that I'm not passionate about the topic or anything. The way the conventional cells that are out there, and this is really inclusive of PERC and TOPCon and heterojunction, and Spencer and Darren did a really good job of explaining this during the presentation, but just to reiterate it, you've got a piece of silicon and you put some metal on the front and some metal on the back, and you kind of daisy chain these together like Christmas lights. So in our cells, all those contacts are on the back side, so you can almost think of two combs that you stick together. So that's the interdigitated part, because these are my digits and they're within each other, right? So it's interdigitated back contact. But what's also pretty unique about our IBC design that's different than a certain historical IBC design that was in the US market from a large Korean industrial conglomerate that's no longer there, is that we use different metal surfacing on the back. So most IBC cells, and even newer ones that we're seeing prototypes coming out of China and stuff, they're still using that metal paste that Darren talked about to stick all those ribbons on. They're just doing it all on the back side. And so while we expect people continue to try to get to ultimately kind of our design with time, these kind of interim IBC steps are ultimately kind of a front contact cell where they've moved all of this screen printed kind of metal paste on the back side. Our metallization process is really fundamentally different and protected by a lot of IP, in that we're really putting a metal foundation, a copper and tin plated foundation, which gives great structural strength to the cell, but also allows it to flex and also allows it to even crack and still pass electricity through without getting dead zones. So thanks for asking what IBC stands for. If you want to hear me talk for another hour, I'll probably start a podcast or something. But anyway, back to you, Christy.
A question about the difference between a SunPower module and a Maxeon module.
As in, just what is it?
Yeah, what's the primary difference between the two?
Got it. Okay, so we call their, and Zach, I'll let you elaborate on this, but we call their module the Max 6 module, and ours the Max 3. No difference in cell architecture or materials. It's simply a difference in cell size. So theirs are a larger format, and ours are smaller, but no difference in cell efficiency or anything like that.
Yeah, in the SunPower at Maxeon name difference, it is really kind of a vestige of the companies amicably separating so they could focus on their things. So that, obviously SunPower has, through its history, when we were one company, built quite a brand in the US, and that company remains based in the US. So retaining the SunPower name was very important for them. Whereas globally, SunPower is also recognized, but SunPower, the corporation, doesn't really exist outside of the US. So it's a little confusing, but basically Maxeon is selling Maxeon panels in the US, and SunPower is selling SunPower branded panels in the US. And once you leave the US, it starts to get pretty confusing because Maxeon, the corporation, is selling SunPower branded panels. But that's kind of the brand taxonomy. I hope that answered your question.
Question here about, and maybe Darren or Zach, you could reiterate. The question is around reasons for failure points in industry average panels that we've engineered out.
Yeah, I'm almost as passionate about this answer as asking what IPC means. So we worked really hard on this. And, if we don't need to pull the chart back up, but you saw a couple big contributors there, right? One was hotspots, and one was the circuitry kind of separating and having problems with that. So by getting rid of those ribbons that are soldered along the length of the cell, that's a huge failure mode that we get rid of. You picture metal, which grows and shrinks a bunch when it gets hot and cold, and silicon, which is really quite stable. It doesn't grow and shrink very much. So every thermal cycle you have, which could just be day and night, summer and winter, it could be on a very hot day of cloud passing, you can have 20 or 30 centigrade temperature difference. All that stuff's growing and shrinking, it starts to fatigue the solder joints. And the same thing happens between the cells. You have kind of a little S curve of that ribbon that goes from the front of one cell to the back of another. And similarly, that's all growing and shrinking, and you got a curve that's kind of growing and shrinking. And if you've ever taken like a coat hanger and bent it back and forth a bunch of times, eventually you get metal fatigue and it breaks, right? So we completely get rid of ribbons, which eliminates that whole chunk of failure mode of circuitry. The majority of what's contributing to the circuitry failure issues. On the hotspot side, our cells, and Darren did a great job of explaining this, but it's very near and dear to my heart, so I'll talk about it a little bit more. Our cells are intrinsically safe when you put them in reverse bias. So to take a step back, when you put a solar panel in the shade or a solar cell, it's trying to keep the same current with all its neighbors, but it doesn't have photons coming in that it can convert to electrons to keep the current of its neighbors. So because electronics get really weird, it starts operating in reverse. So instead of taking outside energy and turning into electricity, it's turning electricity into outside energy. So it's more acting like a toaster than a solar panel, right? So it starts heating up. And there's kind of two things that we've got built into every single IBC cell that we make. One is that the reverse bias breakdown voltage, I'm so sorry, that's a huge mouthful of words, but basically the voltage at which we start to go into that regime is very low. And our current is not super high in our cells. And so if you multiply voltage and current, you get power, right? So if our voltage when we're operating backwards is low, you multiply it by the current, you can have maybe 30 watts of heat that you're having to get rid of out of the cell. If you take a conventional cell, like a PERC cell is maybe around 20 volts. I've heard TopCon is up to 80. We've measured that, but I'm trying to buy more panels so I can have a better opinion about that. I've heard heterojunctions around maybe 40 in reverse bias. So take that times the voltage of the current of the panel, and suddenly with these larger wafers like M10 and G12 wafers, you can have like 13 amps times 20, 40 volts. That's just hundreds of watts of power that you've got to get rid of in a square like this. But that goes to the second difference about our cells that, again, is incredibly unique to our cells, even among IBC cells. And that's that our breakdown occurs across the whole cell. Remember, I talked about the two combs sticking together. The teeth of our combs are super small. And so what that means is when there's kind of this breakdown phenomenon happening, which is almost like the electricity jumping the PN junctions the wrong way, it can, because there's so many contacts across the back of the cell, the voltage, the voltage is low, but the breakdown occurs across the whole surface. In a conventional cell, the breakdown occurs like in a very, very tiny spot. So for us, at the end of the day, you end up with maybe 30, 35 watts that you've got a whole cell area to get rid of. And with the conventional technology, you've got hundreds of watts over, a few square millimeters that you've got to get rid of. And the resultant temperatures in that for us are fine. We've had tests where we had like P-Vel, we paid P-Vel to basically simulate typical shading and yank all the diodes out of the panels. So there's no diode protection, right? And our cells would go up about 20 centigrade and just sit there for hours with no change. Whereas conventional panels would go hundreds of degrees within 2 or 3 minutes. And, I think there was a discussion about this earlier. You've got diodes there, but guys, diodes are like 2 or 3 cents each. They're bought as a commodity. It's a cheap electronic part. And to have something that costs a few $100s relying on a 3-cent component, and a J box in the back before you could have catastrophic panel failures is kind of risky, right? So that probably went a little too deep. I'm sorry, Spencer, for eating some clock time there. But I really, it's a great question, and I really wanted to dig into it because it's a very important differentiator and very unique of our technology.
Yep.
Couple questions here around, one question around warranty registration process.
Yes, we've just launched the website to do this, and we're in short order launching training. So I mentioned that we're launching a channel program in February. The goal is to launch it on February 1st. That would come with a website that any potential installer can access, get an installer number, and then go and register warranties. And the process now is very simple. You need only register one serial number from any one system. The installer can do that, and that's the way it should be done. But if there's a miss there, the homeowner can actually do it as well.
There's a few questions around, can you one more time, can you clarify or reiterate the relationship between SunPower and Maxeon?
Maxeon is SunPower's largest supplier, and they are currently our largest customer in the US market.
Maxeon offer commercial modules in the US?
Yes, in very, very limited quantities. And we are currently sold out for the year. I am lobbying for a lot more commercial modules for 2024, but for obvious reasons, we try to sell as many of these in residential applications as we possibly can. We are severely supply constrained worldwide. So right now, we're only building commercial modules with B cells, so cells that are off color just a little bit. So for now, the answer is yes, but they're spoken for. That should change in 2024.
More questions around AC, the AC availability, or are AC modules available? Will DC modules be available? Maybe just speak a little bit more to the AC ready function of our modules.
So are you guys seeing my screen still?
No.
Okay. So just quickly back to the product. So the only, I guess this is a bit confusing. It says ACR, but again, that means AC ready. So the only module available in the US market this year is this Max 3 112 cell, 410 and 415, which will transition to a 415 and a 420 later in the year. It is a DC module. The ACR just means AC ready. To Zach's point earlier, the cells are strung in a way that lowers the voltage to make it compatible with more MLPE options, but it is a DC module. No AC modules available today. Possibly AC modules available in the future. I mean, I think there almost certainly will be. It's just a matter of when. But current plan is to make them available at some point alongside a DC option as well.
Another question about the warranty. Is the 40-year warranty transferable to a new homeowner?
It is. Easy one.
Yeah.
Yes.
Good.
Next question.
Can you reiterate the difference between the Max 3 and the Max 6?
Yeah,
I'll take a shot at that, Spencer.
Please.
Think of it like you've got brownie mix from Betty Crocker, and instead of making the standard batch size, you're making a double batch. So you just get a bigger pan. Recipes very, very similar between the two. So Max 3, Max 5, which was replaced by Max 6, use fundamentally kind of the same device architecture, but as Spencer said earlier, the wafer size is different. Hopefully that's clear.
Yeah, and to be clear, so we sell a little bit of Max 6 in commercial, but SunPower has exclusivity with that product for the US market for the next few years here. We did that such that Maxeon and SunPower were selling distinctly different, at least module formats here in the US. So there's really no other reason than we wanted to make sure that we weren't selling the same product into the same market.
Is there any special training or certification required to sell this product?
So currently the answer is no. And I want to be clear that the 40-year warranty is available to any customer, regardless of who actually installs the system. That said, per the slide that's up on the screen and my initial comments about the partner program, we will launch a channel program in February. We will launch a tiered channel program, and there will be trainings and certifications and certain requirements that go along with the associated benefits for the Maxeon preferred partner tier and select partner tier. That said, there is also going to be it's not a partner tier, but an installer tier, let's call it, that is agnostic of the channel program. So again, we want to access a different part of the market than SunPower by operating in a different way and offering a different product. In terms of the operating in a different way comment, part of that means flexibility in terms of MLPE, storage, but also how you deal with us, right? So if you want nothing to do with the channel program, you simply want to buy products and sell them to your customers and install them, there is a path for that too. We call those register installers.
A couple questions here about Enphase microinverters. Which Enphase micro do we pair well best with? Zach, do you have thoughts about that? Or go ahead, Spencer.
Yeah, I'd encourage you guys just to, and Spencer, it sounds like you can make it available, the MLPE guide, because there's different considerations depending on your exact install. We're compatible with a lot of them. You can either use our guide or the Enphase design tool, depending on what else is going on with your system.
Yeah, so different for every condition, right? I think the preferred option for Enphase is the IQ8H, which is the highest output for obvious reasons.
I know we're over time. A lot of questions to get to. I think that we should probably try and follow up after this with folks.
Sure. I can stay
but
for another 5 for anyone who wants to.
Great. A couple of these
I'm fine with
questions
that.
around, can we get your contact information? Can we contact the panelists, et cetera? Do you want to provide that, or do you want folks to go through their PCs?
Well, so brass tacks, I will have bandwidth issues in being in contact with, I've got them already as we work to hire up the sales team, right? So this is why we're hiring the sales team, so that we can have direct contact with installers all the time. And in having this exclusive relationship with Green Tech, Green Tech handling the product distribution, our sales team will be free to almost entirely train and support installers. For now, I'm happy to give out my contact info. Just be patient with me in terms of actually getting back to you and getting answers to your questions. I'm bandwidth constrained to answer all the PC's questions at this time. So email address is spencer.collette, it's K-I-L-L-E-T-T-E @maxeon.com. Shoot me a note and I will try to get back to you over the weekend or early next week.
Question around availability, Spencer. Are we confident in sustaining module supply and availability for the long term in the U.S.?
Absolutely. I mean, the U.S. market is a super important market for Maxeon, right? I mean, like I said, we're supply constrained globally on IBC, but in order to launch here as Maxeon, we've committed more megawatts, to this market. So I'm confident in supply today. Will there be a time this year where we are supply constrained? Perhaps, but that's not the situation that we're in today. And we ramp significantly from Q1 into Q2, significantly again from Q2 into Q3, and again into Q4. And there is almost double the megawatts that we've allocated to the US market this year in the plan for next year. So let's create the supply issue. It doesn't exist today. We can certainly supply you.
Will there be a Maxeon storage solution available?
Good question. Probably. And that's all I can say at this time. Zach, do you want to say anything else there?
Nope.
I would guess there will be. We have Maxeon storage in other markets. We're launching it right now in Australia. There's no timeline to bring it to the US, but my guess is yes, it will come to the US.
Yeah, I'll give you a less cheeky answer. So we've launched in Australia. In this quarter, we're launching in Europe, both a storage solution integrated with an EV charger, integrated with services stack, which actually does something useful. It's not just like, hey, your system's making this many kilowatts right now, but trying to provide insights that are actionable that really help people manage their energy better. I'll kind of borrow Spencer's ambiguity. Are we looking at the, what's the plan for the US? I mean, it's something we're looking at, but we don't have any firm timetables right now to talk about.
Maybe one more?
Yeah, and just to reiterate, is the warranty a 40-year warranty standard, or is it 25?
Yeah, it's a good question. So 25 is standard until you register it. So all you have to do is key in name and address of the customer and one serial number from that system, and then it jumps to 40. But if you fail to do that, it's 25.
Yeah, and also note that there's a time window on that, but it's pretty generous. And as well that we don't charge for ownership transfer. That's something that I've seen out there. So it's really made to be pretty simple and transparent for the ultimate customer, right? So.
Great questions, everyone. We're going to make sure to track these and follow up.
Yeah, for everything that didn't get answered, I'd love to, Green Tech folks, I don't know if I can get a copy of the questions. Like I said, I'm not able to see them. Maybe as the presenter, I can only see this one about the Cayman Islands. But I'm happy to get to anything that wasn't answered over the course of next week on the call. And I very much appreciate the attendance and enthusiasm today, guys. We're very happy to be launching in this market with you. All right.
Yeah, thanks, Spencer,
With that-
Darren, and Zach. That was a great technical presentation. I really enjoyed it.
Thanks, Stuart.
Yeah, thanks for the questions and the attention, guys. Really appreciate it.